Hello all, welcome back to my channel once again. So in this video, let's get familiarized with high voltage switchboard room. So yeah, when I was first time assigned to a high voltage chip, I was a little afraid, to be very frank, because I had no exposure to the high voltage chip, high voltage switchboard or the machineries. So I faced some difficulties, I felt some insecurities before going, that I was feeling low and inferior, like how would I handle a high voltage chip and stuff, so on. So I thought, yeah, okay, let's get this video to make the guys who are supposed to join a high voltage chip and let them get familiarized and let them not, make them feel low like me once I faced earlier. So yeah. So this is the high voltage switchboard in my shape, and you see there are a lot of things, colorful things on the switchboards. So actually the one just now I zoomed was the circuit breaker. First thing in high voltage switchboard room, you have to identify like how the power is getting distributed. It is a switchboard. Basically the switchboard gets power from the generator, and from the generator it is getting distributed to the consumers. Oh yeah, you see earthing switch unlock. And to talk about this, any low voltage chip, they don't have earthing. It is an isolated or insulated earthing system, whereas in a high voltage chip it is earthed neutral system. Okay, so that is the difference over here. So first thing I would like to start with the familiarization is by, how to disconnect a circuit breaker from particular machinery. For here, I'm showing about the reefer transformer. So that red switch, first you have to press it down, and the lever over here, it is in the position of engaged position. So you have to make it to center disengage, then insert a rod in the hole, then you have to rotate. And then from engage to disengage position, you have to put it. Okay, as you actually rotate, the circuit breaker actually comes out, it gets racked out, and you can confirm it through the inspection holes. Then the next step is you have to press earthing unlock switch. Now you have racked out the circuit breaker. Now you have to ground it. So in all high voltage chip, first thing for racking out or disconnecting circuit breakers, first disconnect it, then you have to earth it. So this is the one for earthing. So similar to the one, first thing is you have to turn the key, then that lever with number 4, you see that it is in engage position, so put it in a middle position where you see like a headphone. So in that middle position you put, and there is a hole near to that 4, you have to rotate it with the lever, and when you rotate it, you see there is a code that has to come down. That white band should come down like this. It should be fully down. Then you can get to confirm that, yeah, the system is earthed. Okay, so that should come down. And once it got earthed, then the lever that you put in the position, like headphone position, now you have to put it in a vertically totally 90 degree, which means totally the system is disengaged. So that's all. That is one basic thing. Whenever you do any maintenance, that is how you have to do. Then the next thing we can see in a high voltage room is this spider. This is called as a spider. This is also for earthing in particular machinery. When you go to a generator or when you go to a bus bar like shaft gear motor or somewhere, you have got 3 spiders and stuffs. I mean like a spider with the 3 hooks and 1 hook for earthing. And to use that spider, you cannot directly use your hand to earth it. You have to use a handle, proper handle. So this is the thing. So you have to insert those spiders one by one in this handle, and then you have to ground it. So that is how you have to do. At one end you have only 1 spider for earthing, and the other end you have 3. That 3 is meant for 3 different phases. And then we have something called voltage tester. So once you disconnect the ACB, once you ground it in the main bus bar and switchboard, and once you also ground it from the machinery end, now you have to confirm whether the machinery is totally grounded, and also ensure that it doesn't have any static electricity. I mean like the charges, any charges that are holding on into it. So yeah, so you have to verify that using this stick. This stick has two ends. One end you have to keep it at the ground, and the other end you have to keep it at one of the face. You see, the grounding symbol is there. So this particular stick you have to keep it in the ground. The other stick you have to keep it in one of the phases like RST or UVW, either of them. You have to test one by one. Okay, and if there is a charge, then the red light will come on. If there is no any charge, if it is safe to work, then the green light on the voltage stick will show, so that you can further proceed with the maintenance job. So this is the basic thing. And there is something called bus riser in high voltage switchboard. You know what is that? Bus riser. Okay, we come across bus tie, this, that, but there is a bus riser. And where you're finding it? Where number 1 and number 2 bus is actually getting connected. So actually the bus riser is where the number 1 bus bar and number 2 bus bar is connected by using a rising bar, So that is why. And inside this, what is this? These are the AVRs of my generator. Generally, on the books I have studied, AVRs is found on the alternator side locally. But after coming to high voltage ships, I also understand that, AVR also can be present remotely. Those AVRs, they were not lit up because those are responsible generators. Generators are not running in my ship. Rather, we had turbo generators running, and this is an AVR of turbo generator. So here they are powered. So this is AVR of alternator generators, automatic voltage regulators. So this is something interesting. Sometimes it is not that always you can found or you can expect it to found on the alternator side. They can also be found inside the switchboard. And this is an AC system, packaged AC, that is for ECR1. And there you see the AC thing. That is for the high voltage switchboard. That is the intake of the AC. Okay, and you can also find the battery banks, like 110 volt UPS battery banks. So like we have for two, one is for number 1 bus, the other one is for number 2 bus. They are actually, these are the sticks that we were using yesterday for reefer transformers. Alright, we were testing and we just left it. Anyways, so you see again 110 volt. We have number 1 and number 2 banks of 110 volt each. Actually 110 volt is the voltage of the control circuit of this particular high voltage things. And any starter it is like 24 volt or 220 volt you would have seen. In high voltage of my ship, it is 110 volt is the control circuit's voltage. So in case if there is a problem, blackout, and 110 volt is not coming, then via this UPS we are supplying that. And other than that, you see that there is something called GPT. And as I mentioned you earlier, in the books we have studied low voltage ships are insulated earth system, whereas high voltage ships are earth neutral system. So earthing is done via neutral earthing resistors. That is what I have studied in Elston Fernandez book. But on my ship there is no any NER, rather it is by GPT, that is ground potential transformer. So basically this is the earthing of my ship. Okay, so we have transform of it.